Hi friends, good evening. Welcome to GATE Academy. Am I audible? Good evening Lav Kumar, good evening Prachi. Only 6 people are watching. Good evening DK. Am I audible guys? Yeah, fine. So yesterday I think I have given you this question to find out, calculate the stopping side distance and calculate the setback distance. Fine, it is two-lane two-way national highway. Two-lane two-way national highway. Two-lane two-way national highway means this will be the divider and this will be the another lane. Two-lane two-way national highway means here if traffic is in this direction, traffic will be in this direction simply. Fine. So there is no point of this type of collisions will not be there. That means this will be moving in this lane, vehicles will be moving in this lane, vehicles will be moving in this lane. Fine. So there will be only this backward collision. There will not be any onward collision. Since there is no onward collision here, SSD would be equals to simply stopping side distance. How you will calculate this? Vt plus V square upon 2g f longitudinal, right? V square upon 2g f is longitudinal, right? So V is given as 80 kilometers per hour. 80 kilometers per hour, convert this into meters per second. 80 upon 18. 18,472, 4.444, that is 22.22 meters per second. This is velocity. Fine. And reaction time T is given as 2.4 seconds and F longitudinal is given as 0.35. So fine. Now SSD would be equals to Vt plus V square upon 2GF, direct application of formula, 22.22 multiplied with 2.4 plus 22.22 whole square upon 2 multiplied with 9.81 multiplied with 0.35. So the value would be, what is the answer? What is the answer you are getting? SSD you got it as 125.22 meters. Your friend is saying it has 125.22 meters. I don't know how much was that. 22.22 multiplied with 2.4 plus 22.22 square divided by 2 multiplied with 9.81 multiplied with 0.35. So this is 125.22 meters. So you can take SSD as approximately 125 meters. Fine. SSD is 125 meters. Now the next is setback distance. They are asking, just take first case, length of the curve is more than SSD. SD here is SSD. Just assume length of the curve is more than SSD, because nothing is mentioned in the question, you will be taking this. Now based on this setback distance, alpha by 2 would be equals to, this is two-lane highway. For two-lane highway, alpha by 2 would be equals to SD upon 2 into R minus D multiplied with 180 by pi. D value, nothing is given, so you don't have to calculate extra widening here. So W by 4, that is 7 by 4. W plus WE by 4, right? So that would be 7 divided by 4, 1.75 meters. This is the value of D. So alpha would be equals to side distance. Side distance is SSD 125 by 2 into, what is the radius of curve? Radius of curve 200 meters. Fine. 200 minus 1.75 multiplied with 180 by pi. So the value would be 125 multiplied with 180 divided by 2 divided by pi divided by 200 minus 1.75. 18.06. Alpha by 2 equals to 18.06 degrees, and setback distance m equals to r minus of r minus d cos alpha by 2. R is 200 minus of 200 minus 1.75 cos 18.06 degrees. So setback distance would be equals to 200 minus 1.75 multiplied with cos of so answer would be 11.52 meters. Fine. This is the setback distance. You don't have to be. This is the setback distance, m equals to 11.52 meters. Fine. So this is approximately same. Fine. In the question, this is setback distance. In the question, if they ask setback distance from the center line of inner lane, this is the 2-lane road, let us say. This is the center line, right? And we assume that vehicle is kept over here. Vehicle is kept over there. We have taken vehicle is kept in the center line of inner lane, right? When approximately, let us say, vehicle is kept in the center line of inner lane. Now, what we are doing till now is this is inner lane and this is outer lane, right? This is center line of the road. Generally we keep vehicles on the center line of inner lane, right? fine, building will be kept over here, and we are calculating R from the center line, sorry, M from here, M from here. So whenever we talk setback distance we are taking from the center line of the road, center line of the road. If they ask, if at all, that means this value is how much, this value is R minus D, this is also R minus D, and from here to here it is R, this whole thing is R, right? But in sometimes in the question they may ask from the center line of inner lane, setback distance from the center line of inner lane. That means from this lane, if they ask setback distance, they are not asking from here, they are asking from here, from the center line of inner lane. If they are asking setback distance from here, then this would be your M. Fine. So for finding out this M, then R where you will calculate is, if at all in the question if they mention, then only consider this. This would be R minus D. You will consider it from here. Okay. Setback distance from center line of inner lane. Setback distance from center line of inner lane. From center line of inner lane, setback distance from the center line of inner lane. If they are asking from here, then M would be, it is from the inner lane, so it would be R minus D minus of R minus D cos alpha by 2. If they are asking setback distance from the center line of inner lane. If they ask simply setback distance, you can take it from center line of the road. If they are asking setback distance from center line of inner lane, setback distance from center line of inner lane, center line of inner lane. Okay. So if the same question calculate setback distance, we have calculated, and if they ask calculate setback distance from center line of inner lane, from center line of inner lane, from center line of inner lane. So here D also plays an important role. D plays an important role over here. So find out D properly. So for that, what you will do is you will take W plus WE upon 4. Extra widening, how you are going to find out extra widening? WE equals to NL square upon 2R plus V upon 9.5 root R. Okay. Sir, L is not given. If L is not given, I told you have to assume it as 6 meters, right? So 2-lane highway, 2 into 6 square upon 2 into 200 plus you have to substitute V in kilometers per hour, 80 upon 9.5 into root 100. This is extra widening. So the value would be (36) divided by 200 plus 80 divided by 9.5 multiplied with under root of 200. So this would be 0.775 meters. This is the extra widening, fine. And D would be equals to 7 plus 0.775 by 4. 7 plus 0.775 by 4. 7 plus 0.775 divided by 4. So this is 1.94375. You can approximately take 1.94. That is the value of D, and alpha by 2. Alpha by 2 would be equals to SSD upon 2 into R minus D into 180 by pi. Fine. And stopping side distance 125. This is 200 minus 1.94 into 180 upon pi. The value is alpha by 2 would be equals to 0.775 200 minus 1.94. So this is 18.08 degrees. Fine. So setback distance from the center line of inner lane they are asking means r minus d cos alpha by 2. So r minus d is 200 minus 1.94 multiplied with 1 minus cos 18.08 degrees. So the value is 9.77 meters. 9.77 meters. Fine. So this is how you will be finding out setback distance when they are asking it from the center line of inner lane. Be very cautious whether they are asking from center line of inner lane or whether they are, if they simply ask what is the setback distance, then you will calculate from the center line of the road. From the center line of the road it is 11.52 meters. If they are asking you to find out from the center line of inner lane, then it would be 9.77 meters. Fine. Any doubts in this, you can ask me. You can do whatever the way you want to do. So there is no hard and fast rule that you have to do like this only. You can do whatever the way you want to do. There is nothing this one. And you have calculated LC. How you have calculated LC, guys? How can you calculate LC from here? Based on the various assumptions, E value, F value, you have to assume everything, then calculate the curve. That would be a big issue. So instead of that, this would be better. Fine. So just you can't just say that if you do m minus d also, it would be approximately same only, m minus d also. This only difference is 0.2. You won't see much over there. You can do like that also, no issues. So any doubts up to here? If they are asking setback distance from the center line of inner lane, be very cautious. Be very cautious about it. Any doubts, guys? Any doubts? No doubts? Fine. Next one is vertical alignment of the curves. So till now we have seen horizontal alignment of the curves. Now we will be seeing vertical alignment of the curves or vertical curves. In the horizontal alignment of the curves, we have seen super elevation, and we have seen design speed, we have seen super elevation, we have seen extra widening of the curves, we have seen transition curves, and we have seen what is this, setback distance and curve resistance. So please do remember everything and apply it properly in the examination. The next topic is vertical alignment of the curves. In the vertical alignment of the curves, the very first thing that we have to discuss is gradient. Gradient means indirectly slope, longitudinal slope, or if I say gradient is 1 in 10, whenever I say gradient 1 in 10, gradient is 1 in 10. That means for every 10 meters horizontal movement, there is 1 meter vertical movement. Slope is 1 in 10. This theta, tan theta equals to 1 by 10. Indirectly vertical slope like this. Like this. This is the gradient. So vertical curves means the curves will be like this. Horizontal curves means curves will be like this. This is horizontal curve and this one is vertical curves. And gradient, whenever I am talking about this, it's the vertical slope, something like this. That means if road is like this, this slope is called gradient. Tan theta is 1 by 10. Fine. Okay, be very cautious. Horizontal slope, vertical slope. Gradient is vertical slope. Fine. So gradient is generally given as 1 in 10, 1 in 100, 1 into 2000. That means for every 10 meters movement, there is a rise of 1 meter. That is called gradient. In this gradient, there are many things. First one is a ruling gradient. Ruling gradient. Ruling gradient. This is also called as design gradient. Ruling gradient. This is also called as design gradient. This is also called as design gradient. This is also called as design gradient. That means generally this is the maximum gradient that you will design in the given vertical curve. That is called ruling gradient. Gradient which is provided by the designer. I can also take maximum gradient, which is generally provided by the designer. Maximum gradient which is generally provided by the designer for smooth movement of the vehicle. Smooth movement of the vehicle. Maximum gradient which is provided by the designer for the smooth movement of the vehicle, that is ruling gradient. And once ruling gradient is completed, next one is limiting gradient. Limiting gradient. This is the gradient. This is the gradient which is steeper. This is the gradient which is steeper. This is the gradient which is steeper than ruling gradient. Steeper than ruling gradient. Steeper means what? Steeper means slope is more. If this is ruling gradient, this would be limiting gradient. You are getting it? If theta is the ruling gradient, then beta is the limiting gradient. It is steeper than ruling gradient and it is provided in the unavoidable situations. Right? In the places where you can't provide ruling gradient, that means you have to move from this point to this point. Okay? You have to move from this point, you have to provide road from this point to this point, and generally based on your design you got gradient something like this, but that space is not available, or you were not able to take the road from the people, or you were not able to put the tunnel into it. There might be many problems in the field. Because of this you are providing gradient that is more than ruling gradient, that is called limiting gradient. So this is the gradient which is steeper than ruling gradient, provided when cost due to ruling gradient, when cost due to ruling gradient is high. That means for constructing the ruling gradient the cost is high, so we will be providing limiting gradient. But you should not compromise safety with respect to the cost, right. See, that means going, if slope is like this, you can easily go. What happens if slope is like this? Can you go? Do you feel comfortable when you are moving in the 90-degree slope? Do you feel comfortable? You don't, and you can't move. When you are going like this, you will fall. Sir, don't say that, sir. I went to some amusement park, in that they took me to the 90 degrees angle. So every day, every place is not an amusement park. So normally when a vehicle is given to you, you can't drive like this. You can only drive, you can only go like this, right. So just because it is cheaper, you should not construct it like this. Fine. Constructing the road with higher gradient is cheaper compared to that of lower gradient, but you should not construct it like this. So idea is, whenever the cost due to ruling gradient is more, we provide limiting gradient, but safety should not be compromised, but safety should not be compromised with cost. That is limiting gradient, ruling gradient, limiting gradient. Next one is ruling gradient, limiting gradient. Next one is exceptional gradient. Exceptional gradient. So exceptional gradient, it is even more steeper. It is even steeper than limiting gradient. It is even steeper than limiting gradient. It is even steeper than limiting gradient, provided in unavoidable situations. Unavoidable situations means you can't provide limiting gradient over there and you can't provide ruling gradient, then you will provide exceptional gradient. It is steeper, it is not safer, but you don't have a choice. That's why you will provide that. Then you will reduce the speed. You will ask the people to reduce the speed and go very carefully because the gradient is steeper over there. That is exceptional gradient. Fine. Next one is minimum gradient. Minimum gradient, the name itself says minimum gradient. Minimum gradient. Minimum gradient. It is provided. Minimum gradient. It is provided from drainage point of view. From drainage point of view. Minimum gradient is generally provided from drainage point of view. Fine. Generally a gradient of 1 in 500, generally a gradient of 1 in 500 is preferred. Is preferred for local drains, I can say, for local drains, and 1 in 200 is preferred for pakka or kacha drains. Kacha drains means which is not of good locality. If it is of cheap locality or it is of more of mass areas, your drainage should be 1 in 200. 1 in 200 means more gradient. This is less gradient. Fine. For more civilized society, 1 in 500 is better, and for more pakka or local kacha drains, 1 in 200 is preferred. Fine. So these are the different types of gradients, and generally if I have to write, what I can write is minimum gradient is lesser than ruling gradient, which is lesser than limiting gradient, that is further less than exceptional gradient. That is further less than exceptional gradient. Why you are discussing this, sir? Because this point can be asked in your the point can be asked in your engineering services prelims. This point can be asked. That is the reason I have discussed all these things. Any doubts in this? You can ask me. Suraj Shraf, setback distance means. Please go through the yesterday's class. You will get what is meant by the setback distance. Any doubts, guys? Any doubts, guys? And only 7 people are watching. Please do like, share, subscribe with as many people as possible. Any doubts? Comment, 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 comment. Please do comment. Only one person is commenting. Fine. So please do like, share, subscribe, and why even now it is very less. Fine. So this is the gradient. Now if you want to remember, you can remember this table of gradients. Terrain, ruling gradient, limiting gradient, exceptional gradient. Terrain, ruling gradient, limiting gradient, exceptional gradient. First one is plane terrain. So plane terrain or rolling terrains. For rolling terrains or plane terrains, ruling gradient should be 3.3%, limiting gradient is 5%, exceptional gradient is 6.7%. Fine. And mountainous or steep terrain, with elevation more than 3000 meters is 5%, 6%, 7%, and mountainous or steep terrains with elevation not more than 3000 meters above MSL. If it is not more than 3000 meters, then it is 6%, 7%, 8%. This is the minimum gradient that you should be provided. Everything is minimum gradients. Minimum gradients that is generally provided would be plane terrain, rolling terrain, and fine. Mountainous or steep terrain. Here the elevation is more than 3000 meters and elevation not more than 3000 meters above MSL. Please be very clear with this. Fine. Any doubts in this? You can ask me. Any doubts, guys? Balamurugan, good evening. No doubt. Fine. What I have given? This is not minimum gradient, this is maximum gradients. Sorry, this is maximum gradient. If nothing is mentioned in the question, then minimum gradient, if you remember, I have discussed this with you in the chamber concept. Minimum gradient is generally given G equals to 2 times C, where C is the camber of road, camber or cross slope of the road. So G equals to 2 times C. This is the minimum gradient. These are maximum gradients. That means the gradient should not be more than this. As per IRC code, the gradient should not be more than this. So these are that is maximum gradients, and these are minimum gradients. Fine. Please correct it. Fine. Any doubts? Any doubts? Fine. If just take a small question. If camber of road is 1 in 48, what is gradient? The terrain is plain terrain. If camber of road is 1 in 48, what is the gradient? Please give me the answer. Fine. So the answer would be, generally if I ask about the gradient equals to G equals to 2 times C, G equals to 2 into 1 by 48, that is 1 upon 24. Fine. But if you see what is the maximum value in the ruling gradient, 3.3%. 3.3% means 1 by 30. The value is 1 by 30. That means G should not, for plain terrains, G should not be more than 3.3%, should not be more than 1 by 30 indirectly. Percentage is given to you, you can convert into this. So G value equals to 1 by 30. That is the reason you have to remember this whole table. Whenever you are designing anything, if you remember this table, your answer will be solved. Yes, Rick Chowdhury, G equals to 2C is applicable in all types of terrains. G equals to 2C is applicable in all types of terrains, but the maximum value is restricted to this much only. Any doubts, guys? Gradient of steep and hilly terrains, where it is given different, Narendra, where it is given different? Mountainous, steep or hilly terrains, where it is given different? why don't we consider exceptional gradients, sir? See, the Darun, generally we design for ruling gradient. Exceptional gradient means the name itself says exceptional cases, but generally we try to provide ruling gradient only. It should not be more than ruling gradient at any cost. Are you have it differentiated as? Of course, I have differentiated based on height purposes only. So, in the question read properly whether they are saying above 3000 meters, below 3000 meters, go through the IRC code, you will find the same table. I copied it from the IRC code only. What is your doubt? What is your doubt? Narendra? 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 What is your doubt? What is your doubt? No doubts? Fine, thank you. This is the gradient. Fine. The next one is grade compensation. Grade compensation. Grade compensation. When horizontal curve is provided along with gradient or vertical curve. When horizontal curve is provided along with gradient or vertical curve, then there will be more resistance to the tractive force of the vehicle, to the tractive power, indirectly pulling power of vehicle, See, that means you are providing the curve like this, let us say. That means there is horizontal curve as well as vertical curve. Indirectly a spiral type of thing. Fine. That means you are going it like this. Fine. So, if you are providing a curve like this, that is there is horizontal curve as well as there is gradient also. Fine. So, when there is horizontal curve and gradient also, then for pulling power of, that means the vehicle has to apply more amount of power for moving on the roads. So, in that case, you can't provide higher gradients, you have to compensate the grade. That means you have to reduce the grade for it. Fine, that is called grade compensation. This is provided when horizontal curve is provided along with the gradient, then only we are going to, then there will be more resistance to the tractive force, due to which IRC has suggested to compensate the grade, IRC has suggested to compensate the grade or reduce the grade, and as per IRC, grade compensation is not required for gradients flatter than 4%. That means if gradients are less than or equal to 4%, then there is no need of grade compensation. You can keep only 4% only. If gradient is more than 4%, then only you should go for grade compensation, and grade compensation is done when horizontal curve is provided along with the gradient. Generally, grade compensation is given as grade compensation is given as minimum of 30 plus r upon r comma 75 by r. Minimum of these two things will be considered as for the grade compensation, where r is the radius of horizontal curve, where r is the radius of the horizontal curve. Fine. Then compensated grade or compensated gradient. Compensated gradient equals to gradient minus grade compensation. Gradient minus grade compensation. So compensated gradient equals to gradient minus grade compensation. Whatever the grade compensation you are getting, finally you will get compensated grade. Any doubts in this? You can ask me. Any doubts in this, guys? No doubts? Fine. Just take a question. If gradient equals to 6%, radius of horizontal curve equals to 60 meters. Radius of horizontal curve is 60 meters. What is compensated gradient? Please find out. Exceptional gradient criteria is given by IRC. I have given the points that is important from engineering services prelims point of view, not to do some PhDs. So whatever that is important, like what is exceptional gradient, what are the values that is important in the exceptional gradient, that I have discussed, and that is enough for your exam. What is the criteria means what? In the actual field criteria, go and watch the videos that is available in YouTube. So Prachi has given me the answer. How we are going to find out grade compensation? First find out grade compensation. Grade compensation equals to minimum of 30 plus r by r comma 75 upon r. So what is that? Minimum of 30 plus r, 30 plus 60 upon 60 comma 75 by 60. So that is equals to minimum of 90 by 60. 90 by 60 is 3 by 2, that is 1.5, and this is 75 by 60, that is 1.25. Minimum of 1.5 and 1.25 is 1.25. Therefore, grade compensation equals to 1.25, and gradient that is given to you is 6%. Compensated grade equals to gradient minus grade compensation. gradient minus grade compensation. So this is equals to 6% minus 1.25%, that is 4.75%, more than 4%, therefore it is okay. Fine. So the compensated grade is 4.75%. Any doubts in this? You can ask me. If you have a question on that, ask me the question. I'll discuss with you directly personally. You can ask me the question, no issues with that, or now also you can ask me the question, no issues with that. I'll discuss that. Any doubts in this? You can ask me. Fine. In the same question, if gradient is 5%, what would be the compensated grade? If gradient is 5%, what is the compensated grade? Give me the answer. You people have done this course, I think. You are giving me the answer. Anyway, what is the answer? Narendra, you can ask me the question. I will discuss that in the class. No issues with that. Fine. So people have given that as 4%. Radius of curve is same. It is not going to change. Minimum of these two things is this one, that is 1.25 is the minimum. So grade compensation is 1.25 and gradient that is given to you is 5%. From this compensated grade equals to gradient minus grade compensation. So what is the gradient? 5% minus 1.25%. So 3.75% you said. I said grade compensation is not required if gradient is flatter than 4%. This is less than 4%. That means compensated grade equals to 4% only. Compensated grade equals to 4% only. So whenever the value is, if it is less than 4%, answer would be 4%. You will not give 3.75%, you will give answer as 4%. Whatever the question it is, whatever the exam it is, answer would be 4%. If it is more than 4%, then you will go, like in the previous case it is more than 4%, so answer is 4.75. Here it is 4%. Fine. So IRC has suggested this, that gradient should not be flatter than 4%. Balamurugan, I am from South Indian, sir. Lectures are very helpful to understand for is better, and I really thank you for your academy. Thank you very much for your kind words, Balamurugan, and please do follow, like, subscribe and share. सर मोस्टली न्यूमेरिकल गेट के टाइम पर किया था, थियरी वीक हो वो ज़्यादा नहीं पढ़ाया था सर, इसलिए फाइन. आई विल डिस्कस मोर थियरी कॉन्सेप्ट्स. एन एक्सेप्शनल ग्रेडियंट मे बी प्रोवाइडेड अप टू 1/12 along hilly roads if length does not exceed dash meter per kilometer. Wonderful question which I didn't understand anything. Please send it in the WhatsApp, the question. Next one is limiting length of the grade. Limiting length of the grade. Limiting length of the grade. So what exactly is meant by limiting length of the grade? Limiting length of the grade. So any idea what is limiting length of the grade? It is the maximum length. It is the maximum length. It is the maximum length that can be traveled by the vehicle on the grade without much reduction in speed. It is a maximum length that can be traveled on the grade. That means whenever the vehicle is moving on the gradient, whenever the vehicle is moving on the slope, when you are going up, what happens? Your speed reduces. So you should, the maximum reduction, that means generally the maximum reduction in speed, it should not be more than 25 kilometers per hour. Maximum reduction should not be more than 25 kilometers per hour. That means if you start with 80, the up to 65, your speed will reduce. Let us say here it is 80. 80 minus 25 is 55. Fine. So here the speed might be 80 kilometers per hour. Here it is 55 kilometers per hour. This length is called as limiting length of grade. Limiting length of grade. In a simple words, this is the limiting length of the grade. Any doubts in this? Any doubts in this? Reduction in speed should not be more than 25 kilometers per hour. So whenever the vehicle is moving on the upward gradient, the reduction in speed should not be more than 25 kilometers per hour. That means, for example, if it is 80, this is 55, the length traveled when the speed reduces up to the 55, that is called as limiting length of the grade. Any doubts in this? No doubts? Fine. It's already 1 hour. I thought of discussing summit curves and valley curves also. Anyway, I'll discuss that tomorrow. With this, if you are having any doubts, you can ask me. Narendra, you can WhatsApp me the question. I'll discuss it tomorrow. No issues with that. And till this point, I don't think so you are having any doubts. If you are having any doubts, you can ask me. If not, this is Karthik Mandalappu signing off. Good night. I asked them for it, Narendra. I'll let you know as soon as possible once I get the clearance. हाँ लास्ट क्वेश्चन पे सर वो assertion reason वाला क्वेश्चन देख ले प्लीज. I'll discuss that question. Don't worry about that, प्राची. April होने वाला है. I'll make sure that you'll complete everything. Yeah, the actual compensation would be not 1.25%. The actual compensation is 1% only. If compensated grade is 4%, then actual grade compensation is 5 minus 4, that is 1%. Actual grade compensation is 1% only. Fine. Any other doubts? No doubts? Fine, bye, good night.